This is section 6.2, and we'll be talking about graphs of exponential functions. So let's look at the characteristics of the graph of the parent function f of x equals b raised to x. Now, this function right here, b has got to be greater than 0 and b cannot be equal to 1, and we discussed that in our earlier video, why those two things have to happen. Now, it has these characteristics. It is a one-to-one function. It has a horizontal asymptote at y equals 0. The domain is all real numbers, goes from negative infinity to positive infinity. The range goes from 0 to infinity. It has no x-intercepts because the horizontal asymptote is at y equals 0, so it doesn't cross the x-axis. The y-intercept is 0, 1. And if b is greater than 1, you have an increasing function. And if b is less than 1, and also if b is between 0 and 1, you have a decreasing function. Okay, so let's look at the graphs here. So if b is greater than 1, then what we have here is an increasing function like this right here. Okay, now notice we've got two key points here. One key point is 1, b. So whatever b is here, because b will be a number, then you'll have a key point at 1, b. And also, for this function, before we do any types of transformations, f of x equals b raised to x, that will go through the point 0, 1. Okay, now if b is between 0 and 1, then what you have is a decreasing function, and you still have those two key points, 1, b and 0, 1. Okay, now it talked about this being a one-to-one function. So, get rid of my markings. So that passes the horizontal line test because it only intersects that line at one point wherever you go. Okay, same thing over here, so it's 1-to-1. And since it says it's a one-to-one function, that indicates that it's already a function, because it can't not be a function and be a one-to-one function. That won't work. And notice the graph here is going closer and closer and closer to the x-axis, which that's another thing is saying y equals 0. So it'll get really, really close to it, but it will not touch it. It will not cross it. Okay. And let's see. The domain goes from negative infinity to infinity. So for your x values going to negative infinity, it keeps just on going. For your x values going to positive infinity, your function just keeps on getting bigger and bigger and bigger, picking up more and more and more x values. And your your range goes from 0 to positive infinity on both of these. So domain and range the same on both of these. So notice how it gets really close to 0, and we said that that's y is equal to 0. So it starts at 0 but does not include it because it never actually gets to 0. And then it goes up forever to positive infinity. Same thing over here. It gets really close to 0, but it never touches 0. And then it goes up to positive infinity for y. So that would be your range. And it doesn't have any x-intercepts because of your horizontal asymptote being y equals 0. So it never gets to the y-axis, which is y equals 0. So you don't have any x-intercepts. Now let's look if we shift the parent function. So for any constant c and d, the function f of x equal b raised to x plus c plus d shifts the parent function f of x equals b raised to x. So what it's saying is this right here is going to move it vertically that many units, either up or down. If it's negative, it'll move it down. If it's positive, it'll move the graph up. It'll move it horizontally in the opposite direction of the sign. So remember, if we had, let's say 2x minus 5, then because of this minus sign, we're actually going to go to the right 5 units. If it was a plus sign, we'd be going to the left 5 units. It also has a y-intercept, which would be 0, comma, b raised to c plus d. So for this one, we would have 0, comma, b, which would be 2, c, plus, in this case, we have 0. Okay, so there'd be 0, comma, and then 2 raised to itself 5 times, or sorry, 2 raised to 5, or 2 times itself 5 times, which would be 32. Now the horizontal asymptote becomes y equals d. So whatever this value is right here, that's going to be your y asymptote, or actually your horizontal asymptote. Now your range becomes d, starts at d and it goes to infinity, and your domain doesn't change because it's already including all the real numbers. So if you shift it to the left or to the right or up or down, it's not going to affect it. It's just going to be all real numbers. Okay, so let's look at this one right here. We're going to graph the function f of x is equal to 2 raised to x plus 1 minus 3. We'll state the domain, the range, and the asymptote. Okay, so I need my two key points. Let me get rid of all this. Okay, so one of my key points would be this one right here. So one of my key points would be b raised to c. Sorry, this should be a 0 there first. 0, comma, b raised to c plus d. Now our b is 2, our c is 1, and our d is negative 3. So we got 0, comma, 2 raised to 1 minus 3. So that is 2 minus 3, so that is 0, negative 1. I'll write that over here. Okay, we'll get rid of all this. And then we had, in the parent function, we had a key point, and it was right here, y equals 0, comma 1. Now, what happened over here? So let me write 0, comma 1. That's for the parent function. Now, what happened is we moved the parent function, number 1, down 3 units, and that's the y. That affects the y values. So I'm going to subtract 3 from my y values, so I get 0. 1 minus 3, that's negative 2. And then we moved to the left by 1 unit. So I'm going to subtract 1 from my x values. So that'll be negative 1, negative 2. So there's another point I can plot. So negative 1, comma, negative 2. Okay. And then let's look at b. Okay, b is 2, so that's greater than 1. So that means we are increasing. It's an increasing function. Okay, and we also need to find our y, or our horizontal intercept, or sorry, asymptote. So horizontal asymptote. That is just y is equal to whatever d is. Here d is negative 3. Okay, so at negative 3, our graph will not cross this point or this line. Okay, so we have an increasing function. So it'll be going something like this right here, be increasing. We have the horizontal asymptote. We'll go ahead and plot those 2 points, negative 1, negative 2, right here, and then 0, negative 1, right here. Okay, so looks like our function will look like this right here. Okay, so let's state the domain. Well, that one should be easy because for the exponential functions, it's always going to be from negative infinity to positive infinity. Our range, remember, it starts at D. That's what it says over here. Starts at D, goes to positive infinity. So our D is -3, goes positive infinity. And we said that we don't include the -3 because the -3 is actually our horizontal asymptote, so we never get to -3, but we get really, really close to it. So it starts somewhere close to -3, and then it goes up to positive infinity. And then a horizontal asymptote, we had already listed that, but we'll list it over here. So y is equal to -3. Now, if you graph this right here, this is essentially what it's supposed to look like. And notice here's our 0, -1, and then here's our -1, -2. And notice it's getting closer and closer and closer to 3. It looks like it actually gets to 3, but when you zoom in on this, it's not actually touching it. They're actually it's a very small distance between the two. And then it's also an increasing function. Okay, now let's look at this one. So what has changed is we have 2 raised to x minus 1 plus 3. So let's look at our key points. So we'll have 0, 2 raised to -1, because our b is 2, our c is -1, and our d is positive 3. So plus 3. So we got 0, that's 1/2 because I got a negative exponent, plus 3. Okay, I'm going to come over here, 1/2 plus 3 over 1, multiply that 2 over 2 to get the denominators the same. So 7 over 2, which that is 3.5. And we'll go ahead and write this over here. So we've got 0, 3.5. Then let's look at the key point from our parent function and see if we can figure out what happened to it when we shift it. So this is the parent function. Okay, so I went up 3 units, and that's going to affect the y, so plus 3. So 0, 4. And then I move to the right by 1 unit. So I'm going to add 1 to my x value, so that'll be 1, 4. Okay, so 1, 4. Okay, let's look at b. b is 2. So b is greater than 0. It's equal to 2, so it's increasing. We have another increasing function. We have a horizontal asymptote at y is equal to 3. We'll go ahead and state our domain, -infinity to positive infinity, and our range will start at whatever d is. Here d is 3 and goes up to positive infinity. Okay, so 3 is our asymptote. So right here, we're increasing. Let's go ahead and plot those 2 points. 1, 4 right here, and 0, 3.5. So about here. Okay, so then make an increasing function and get really close to this horizontal asymptote. Now this is what it looks like, or should look like. There it is right there. Notice we've got a horizontal asymptote at y equals 3. Here's our point 1, 4, and here's our point 0, 3.5. Notice how it's halfway between the 4 and the 3. Now let's look at this one right here. Again, we'll look at our key points. Here b is 1/3, c is -4, and d is -8. So we'll have 0, 1/3 raised to -4 minus 8. -4 is going to flip what's inside, so 3 raised to 4 minus 8. Okay, so we'll have 0, and this will be 81 minus 8, so 0, 73 for one of our key points.